It's all in or nothing. 12 schools are through to the semi-finals where they will be faced with tough, real-world problems to solve. Who will rise to the challenge? And most importantly, who will go on to the grand finals? Find out all these on the National STEM Championship.
Welcome to the National STEM Championship 2022. I'm Sonia Chu. Now, with the qualifiers and quarterfinals done and dusted, it's time for our 12 teams to bring on their A game in the semi-finals. Here's what's going to happen. Teams will be awarded points based on their performances in 4 different challenges held in separate locations. And only the teams with the highest amount of overall scores in each semi-final will move on to the grand finals. So without further ado, let's meet the teams from semi-finals 1.
A very big welcome to Swiss Cottage Secondary School, CHIJ St. Nicholas Girls School, and School of Science and Technology Singapore.
Our schools go head-to-head in a challenge at the Singapore University of Technology and Design, SUTD. Now, established in 2009, the school aims to advance knowledge and nurture technically grounded leaders and innovators, which sounds like a great place for them to receive their challenge, right? But first up, our contesting schools will be brought around for a tour. Let's join them, shall we?
Welcome to the Singapore University of Technology and Design. I'm Professor Carlos Bagnon, and I will be with you today for an exciting challenge. As you know, in design, sustainability and optimization of resources is a crucial thing, and that's why we're pushing 3D printing.
So this works sort of like a laser cutting machine, but this uses water instead of lasers.
You're going to use the 3D pen to directly manufacture a structure.
In these 45 minutes, we'll learn how to use the 3D pen, which is the crucial equipment that will be used for the challenge later. So you'll need to control your hand speed according to the flow of the material. The material will coil up like that. You want the material to be flat. Like just let the nozzle touch the nozzle. Yeah, let the nozzle touch the nozzle. Let it be flat.
For today, we have this challenge for you. So we're gonna design for sustainability as a premise here, and we're gonna use additive manufacturing. So additive manufacturing, which is 3D printing, is a way that we can decide where to place the material. We're gonna spend 1.5 hours fabricating a design that is able to withstand the weight of a dish and some marble threads. So the requirements is that the structure must be at least 10 cm tall, and second, gonna be bigger than 10 by 10 cm in the base. I really encourage you to come up with bold ideas, to think how the forces travel through the structure, where do you need more, where do you need less, in order to rigidize, to really make it like withstand the load, but also keep in mind some aesthetics. And if you can come up with a powerful concept as well, your narrative is there as well, that will be a round product for you. So the concept, which is for us very important, right? You're experimenting, exploring certain ideas of connectivity, of bifurcation, or redundancy, or something like nature-inspired. Then mass of structure. So the lightest structure will be scored the highest. So can we save material? But be careful. I mean, you need material to support the weight, but you need to place it wisely. Third, aesthetics. So it's not adding decoration to it. It's actually something that performs well and follows a rational principle. That's why the aesthetics are there. Then the structure must be able to withstand the loads. So the load is gonna be the vertical load, is gonna be also the shaking platform, all right? Both of them, so need to pass this test.
At first, we based our design off the Taipei 101 because Taipei 101 had a pendulum on the top floor. So when the building was shaking, the pendulum would exert a force downwards that would keep it in space shape. Our original idea with the beam support tube holding it up was around the same thing, something that was not as rigid but could still hold immense amounts of force.
Guys, can you ensure the height is 10 cm?
It's just nice.
Just nicer.
We took inspiration from the fact that actually we are supposed to build a tall structure, so it kind of looks like skyscrapers.
At the start, we had several iterations of the ideas, which allowed us to come up with all the flaws that the structure could have and work on them so as to get a really optimized final product.
Sustainability is a key factor in all designs, and students have cleverly drawn from real-world architectural inspirations to boost their structures. Now the question is, will their structures withstand the test on the shaking platform? We'll find out after the break. Keep it right here on the National STEM Championship. Welcome back to the first semi-finals of the National STEM Championship. Now, all eyes are on Swiss Cottage Secondary School, CHIJ St. Nicholas Girls' School, and School of Science and Technology, Singapore. Now, they spent the past 1.5 hours building their structure with a 3D pen. But the question is, will they be able to withstand the test on a shaking platform? Let's find out.
Oh no, I heard that an earthquake is coming soon. I'm very worried about our building. It may topple. Should we go and find an architecture firm to help us solve that problem?
Yes, go.
We chose the design of the crabs because the legs are arched, and arched legs will provide more reinforcement and have a lower center of gravity. Being closer to the ground, it will not wobble as much.
And also, as you can see here, we have also added a cylinder in the middle to increase the area of contact of the dish with our structure. So with the increase in area of contact, there will be an increase in friction. Hence, there will be more stability.
Swiss Cottage took a very bold move with building like almost these crab legs, and that's very hard to do, right? So I give them full credit for that. One thing is that the middle column wasn't too useful to the entire structure, and it detracted away from the overall concept of the initial form.
I think something that could improve the performance is to connect the central piece maybe to the top, or to make it more part of the whole structure.
We actually did try to connect it towards the bottom. However, due to the time constraint, we weren't able to reinforce that and make the connection line thicker and bolder.
Today, all around the world, buildings, no matter how tall or how short, all face the same danger of earthquakes. These buildings all face the risk of collapsing because the earthquakes are shaking their foundations. Hence, Skyscrapers has designed a structure to withstand both vertical and horizontal forces.
For the ideation part of our structure, we split it into the top, middle, and base. So for the top, we have this structure to hold the dish. And for the middle, we have a trapezium shape with many triangles within the shape, as well as a base. And we tried to maximize the 10 cm by 10 cm so that it would increase the base area so that we can improve stability.
CHIJ has a very conventional approach, but they paid a lot of attention to the aesthetics. I thought generally they did super well.
They were very clear-spoken, and they were trying to sort of teach how they made the structure by coloring it in a certain way.
So first, let's talk about the actual design itself. So as you can see, we mainly use like a frustum-like design. So imagine taking like a square prism by cutting off the apex. So that's basically what we did. And then not just that, we use these trapeziums to help hold up the dish itself. And then we also have inner trapeziums holding at the diagonals of the base.
So what we did was we added more mass to the base of the structure so as to lower the CG and make it more stable when dishes are added to the top of it. We prepared for our presentation quite elaborately and really brought out the really important aspects of the design process of this structure.
So obviously, we didn't immediately come up with this design. We had a bunch of iterations. The first thing that everyone will think of, oh, just make a cube, because first off, it's the lightest mass, so therefore a better score. But the problem is, it's not that stable.
SST did quite well. I like the way they presented the method. They went through a few iterations and they made it very clear what were their thought processes.
So now we can test it.
36 grams. Ready? And go.
We had several issues when prototyping, particularly when leveling the prototype so it wouldn't tip over. The fact that it was able to achieve such immensely well results was quite surprising, I'd say.
The final score will be 5 marbles and 6 dishes. 22.2 grams.
I think we are quite happy with our results today. We kind of had more dishes and more marbles than we kind of expected.
The final score will be 6 dishes and 6 marbles. 37.8 grams. You can straighten it. And go. So the final score is 5 dishes.
We didn't really expect to manage to hold up 5 trays because the more trays are obviously it's going to add a lot more shaking. Luckily, we managed to hold a decent amount of mass.
Well done to our 3 teams. They've built their structures with real-life scenarios in mind, just like building a tower strong enough to withstand an earthquake. But the question remains, who is going to move on to the grand finals? Congratulations, CHRJ St. Nicholas Girls' School. You managed to balance 6 dishes and 6 marbles on your structure. We'll see you in the grand finals. And that was the first round of the semi-finals. Let's move on to meet our next cluster of semi-finalists. Now remember, each team will be awarded points based on their performances in 4 different challenges. Only the teams with the highest amount of scores overall in each semi-final will move on to the grand finals. Now let's meet our 3 teams who will be competing at A-Star's Advanced Remanufacturing and Technology Center.
Put your hands together for River Valley High School, Hwa Chong Institution, and NUS High School of Math and Science.
Hello guys, welcome to ARTC or Advanced Manufacturing and Technology Center. My name is Atika. Welcome. Congratulations on making it to the semi-final. So for today, your team is actually engineering. So let's do a quick tour around ARTC before your actual challenge begins. Alright, let's go.
The expertise of ARTC lies in automating processes. Combine research and application, and you get innovative industrial solutions. Pretty nifty, huh? This might give a hint of the challenge that awaits.
I'm going to introduce to you your challenge. So you are a team of engineers now, so just keep it in mind. You are to design an automated vaccine inoculation device to help the healthcare workers to draw the accurate volume for COVID-19 vaccination process. So you have 120 minutes for the challenge. We are looking for advanced automation. You can think about including sensors, user-centric design, and also empathy. In total, there are 3 parts of the challenge, A, B, and C. The first one is the importance of removing the bubbles. For challenge B, it's more user-centric design. So you have to think about how are we going to load, unload the syringe. We are also looking for innovation, overall novelty of the design. How feasible is your idea? Is the proposed solution achievable with the existing technology, or you have to create a new technology?
We came out of the design after watching the video that they showed us during the introduction briefing slides. We saw how the nurses typically fill up the injection needle. From there, we also drew inspiration from the ARTC tour that we had before the challenge, where we saw how they use machines to automate production process.
I think the most underlying concept or what we were aiming for is automation. We wanted to make most of the processes involved with filling the syringe automated so that it's efficient and nurses don't have to struggle with this process. It requires a lot of calibration as well.
So while coming up with the design, there were 2 parts that we had to take into consideration. One is the question statement itself, and secondly is just the physical construction of the prototype. It is actually something quite new to us to construct a physical prototype and display it to the judges while giving a presentation.
Scientists are always looking for better ways to automate processes and eliminate human error. Now, our students will be judged based on how automated their solution is, the usability of their design, innovativeness, and also how feasible it is based on today's technology. Now, with this huge task ahead of them, they will be given things like syringes, wooden pegs, cardboard, and a whole host of materials. Now, I'm really excited to see how their solutions will turn out. Let's take a look after the break. Welcome back to the National STEM Championship. We are in the midst of the semi-finals right now, and the focus is on River Valley High School, Hwa Chong Institution, and NUS High School of Math and Science. They've spent the past 2 grueling hours building their concepts that will automate the process of drawing a vaccine from a vial. And it's come down to this, judgment time. They will only have 3 minutes to present their concept, so all the best, students.
Ouch! Hiya, pain is it? My job as a nurse is even more painful, you know?
Exactly. That is why we three, as medtech engineers, have engineered a solution for easy vaccine extraction.
We'll start off with the input. The first step is to uncap the syringe. After that, you'll sterilize the vials using isopropanol misting. We will also need the nurses to key in some key details about the vaccine type and also the dosage.
Oh, so you guys made the machine that I received yesterday. I know how this works. You load up the vials on the top rack and load up the syringes on the bottom rack, and you lock them up, and the vials will be lowered onto the syringes, and the suction actuators will grab onto the plunger and extract the medication.
NUSI, they are technically very sound, and they have some really good advanced concepts. They have a very strong foundation, especially in science. And if you look at the design, it's simple but not oversimplified. It ticks all the right spots, all the right boxes.
Our machine is extremely efficient because not only is the dispensing extremely fast, the error correction and the sonication, along with the scanning, will be very quick as well. This is actually also very novel because the uses of sonication and suction caps, as in our design, is also not very widely used in other contraptions.
Almost a little bit too simple if you look at different parts of it. But when we probed them for why did you have this design consideration, why this, why that, they were very ready to offer their rationale behind it. And also they talked about the alternatives that were rejected.
For an engineering challenge as a math and science school, we did our best, and I think it was a pretty good effort because we were quite close to the solution. We're all very happy with the result, and we have a good chance of getting to the finals.
Introducing AVID, Autonomous Vaccine Inoculation Device.
How do you use it?
Well, first of all, you need to put in the vial and the syringe at the start of the conveyor belt. And then the central rotary actuator will rotate the 3 belts, and the vial and the syringe will be moved to station 1.
The main goal of our illustration was to present a complex 3D design onto a simplified 2D drawing. What we did was first we drew out the interior as well as the exterior of the different parts of the system, how it worked together. And we separated it into 3 main stations. For example, firstly, how the linear actuator helps to uncap it and pulls back the syringe. And the second stage, where the rubber flap helps to reduce the air inside the syringe. And at the last stage, where we actually cap back the syringe and it goes back to the conveyor belt.
I would say it's a very sophisticated design, and so what I really like about the process is it is continuous, so it's possible then to have a large volume. However, it's complicated for a reason. Engineering-wise, it's very intensive, and also may incur some costs. But I think the elements of this concept, it's all there. So I quite enjoyed that.
It was elaborate. They had a continuous loading mechanism, which possibly very useful in a situation where you need to deliver a large number of doses in a small amount of time. I think it could be refined a little more, but definitely very innovative too.
Because of the need for automation, we actually brought in a lot of actuators. So linear actuators, the central rotary actuator, and that may have made the overall system a bit more complicated, but at the end of the day, it automates the entire process. So there's really literally no need for hands-on operation.
Oh no, there are so many patients, and every single time I have to refill the syringe with the vaccine, but my eyes are getting tired. If only there were a way to skip over the vaccine filling process.
Right now, with our product Lock and Load, you can do it easily. So firstly, there's a screen function over there, which is the red color box, which has a start loading thing. So you can press yes, and then when you start loading.
What I liked the most about River Valley was their presentation and their impersonation of how they would operate the device. And they really included the interface, the user interface, so that the nurse, when they would use, they would have to choose, they would have instruction popping in. The machine would be able to recognize some defects. And I think the way the user would use the machine was very well captured with this goal.
And what is going on inside the machine? Firstly, the caps are being removed by this tray below and will slide behind. Now this whole tray will flip over and the bottles on top with another layer will be brought downwards.
To me, it feels a little bit like a vending machine for vaccination almost. If you have 25 of these running in, I could just push my shoulder against this and then just wait for things to load. And if I place my shoulder in the right place, it might do the vaccination for me. Very nice.
I feel it's a compliment because vending machines are being implemented very widely and are also very relevant to the society. So them comparing our futuristic machine to one that is very relevant to the society and very able to be implemented feels like a very good compliment for us.
I found that every one of the solutions they proposed was a valid one. And I couldn't honestly find many flaws in what they were proposing.
Well done to our 3 teams for coming up with such jaw-dropping concepts. Now we're left with one last question. Who's moving on to the grand finals? Give yourselves a high five and a big hip hip hooray to NUS High School of Math and Science. They joined CHIJ St. Nicholas Girls' School as the first 2 schools to qualify for the grand finals. Congratulations! 2 more teams will be joining them in the grand final. Who will they be? Find out in the next episode of the National STEM Championship. Now, we'll also be visiting a global company that manufactures aircraft engines. We'll be putting shock absorbers to the test. I wonder why and how. All that and more in the next episode of the National STEM Championship. I'm Sonia Chu, and I'll catch you next time.
Now the problem we are facing is going there.
Ami!